Welcome to Configuring Unidirectional Link Detection. The following are restrictions for configuring unidirectional link detection. A UDLD-capable port cannot detect a unidirectional link if it is connected to a UDLD-incapable port of another device. When configuring the mode, normal or aggressive, make sure that the same mode is configured on both sides of the link. In the initial phase, the number of ports on which fast UDLD can be enabled is limited to 32. If this number is reached, then fast UDLD is not enabled on additional ports and an error message will be printed on the console. LoopGuard works only on point-to-point links. We recommend that each end of the link has a directly connected device that is running STP. Information about UDLD. Unidirectional Link Detection, UDLD, is a Layer 2 protocol that enables devices connected through fiber optic or twisted pair Ethernet cables to monitor the physical configuration of the cables and detect when a unidirectional link exists. All connected devices must support UDLD for the protocol to successfully identify and disable unidirectional links. When UDLD detects a unidirectional link, it disables the affected port and alerts you. Unidirectional links can cause a variety of problems, including spanning tree topology loops. Modes of operation. UDLD and fast UDLD support two modes of operation: normal, the default, and aggressive. In normal mode, UDLD can detect unidirectional links due to misconnected ports on fiber optic connections. In aggressive mode, UDLD can also detect unidirectional links due to one-way traffic on fiber optic and twisted pair links into misconnected ports on fiber optic links. In normal and aggressive modes, UDLD works with the Layer 1 mechanisms to learn the physical status of a link. At Layer 1, auto-negotiation takes care of physical signaling and fault detection. UDLD performs tasks that auto-negotiation cannot perform, such as detecting the identities of neighbors and shutting down misconnected ports. When you enable both auto-negotiation and UDLD, Layer 1 and Layer 2 detections work together to prevent physical and logical unidirectional connections and the malfunctioning of other protocols. A unidirectional link occurs whenever traffic sent by a local device is received by its neighbor but traffic from the neighbor is not received by the local device. Normal mode. In normal mode, UDLD detects a unidirectional link when fiber strands in a fiber optic port are misconnected and the Layer 1 mechanisms do not detect this misconnection. If the ports are connected correctly but the traffic is one-way, UDLD does not detect the unidirectional link because the Layer 1 mechanism, which is supposed to detect this condition, does not do so. In this case, a logical link is considered undetermined, and UDLD does not disable the port. When UDLD is in normal mode, if one of the fiber strands in a pair is disconnected, as long as auto-negotiation is active, a link does not stay up because the Layer 1 mechanisms detects a physical problem with the link. In this case, UDLD does not take any action and the logical link is considered undetermined. Aggressive mode. In aggressive mode, UDLD detects a unidirectional link by using the previous detection methods. UDLD in aggressive mode can also detect a unidirectional link on a point-to-point link on which no failure between the two devices is allowed. It can also detect a unidirectional link when one of these problems exists. On fiber optic or twisted pair links, one of the ports cannot send or receive traffic. One of the ports is down while the other is up. One of the fiber strands in the cable is disconnected. In these cases, UDLD disables the affected port. In a point-to-point link, UDLD hello packets can be considered as a heartbeat whose presence guarantees the health of the link. Conversely, a loss of the heartbeat means that the link must be shut down if it is not possible to re-establish a bidirectional link. If both fiber strands in a cable are working normally from a Layer 1 perspective, UDLD in aggressive mode detects whether those fiber strands are connected correctly and whether traffic is flowing bidirectionally between the correct neighbors. This check cannot be performed by auto-negotiation because auto-negotiation operates at Layer 1. UDLD operates by using two methods: neighbor database maintenance, event-driven detection, and echoing. Neighbor database maintenance. UDLD learns about other UDLD-capable neighbors by periodically sending a hello packet, also called an advertisement or probe, on every active port to keep each device informed about its neighbors. When the device receives a hello message, it caches the information until the H-time, hold time, or time to live expires. If the device receives a new hello message before an older cache entry ages, the device replaces the older entry with the new one. Whenever a port is disabled and UDLD is running, whenever UDLD is disabled on a port, or whenever the device is reset, UDLD clears all existing cache entries for the ports affected by the configuration change. UDLD sends at least one message to inform the neighbors to flush the part of their caches affected by the status change. The message is intended to keep the caches synchronized. Event-driven detection and echoing. UDLD relies on echoing as its detection operation. Whenever a UDLD device learns about a new neighbor or receives a resynchronization request from an out-of-sync neighbor, it restarts the detection window on its side of the connection and sends echo messages in reply. Because this behavior is the same on all UDLD neighbors, the sender of the echoes expects to receive an echo in reply. If the detection window ends and no valid reply message is received, a link might shut down, depending on the UDLD mode. When UDLD is in normal mode, a link might be considered undetermined and might not be shut down. When UDLD is in aggressive mode, a link is considered unidirectional, and the port is disabled. UDLD reset options. If an interface becomes disabled by UDLD, you can use one of the following options to reset UDLD. The UDLD reset interface configuration command, the shutdown interface configuration command followed by the no shutdown interface configuration command restarts the disabled port. The no UDLD, aggressive enable, global configuration command followed by the UDLD, aggressive enable, global configuration command re-enables the disabled ports. The no UDLD port interface configuration command followed by the UDLD port, aggressive, interface configuration command re-enables the disabled fiber optic port. The error disable recovery cause UDLD global configuration command enables the timer to automatically recover from the UDLD error disabled state, and the error disable recovery interval global configuration command specifies the time to recover from the UDLD error disabled state. Default UDLD configuration. UDLD global enable state is globally disabled. UDLD per port enable state for fiber optic media is disabled on all Ethernet fiber optic ports. UDLD per port enable state for twisted pair, copper, media is disabled on all Ethernet 10/100 and 1000 base TX ports. UDLD aggressive mode is disabled. Fast UDLD per port enable state is disabled on all ports. Specifies the UDLD mode of operation. Aggressive, enables UDLD in aggressive mode on all fiber optic ports. Enables UDLD in normal mode on all fiber optic ports on the device. UDLD is disabled by default. An individual interface configuration overrides the setting of the UDLD enable global configuration command message timer. Interval configures the period of time between UDLD probe messages on ports that are in the advertisement phase and are detected to be bidirectional. The range is from 1 to 90 seconds. The default value is 15. Note: this command affects fiber optic ports only. Use the UDLD interface configuration command to enable UDLD on other port types. Use the no form of this command to disable UDLD. Returns to privileged exec mode. Enabling UDLD on an interface. UDLD is disabled by default. UDLD port enables UDLD in normal mode on the specified port. UDLD port aggressive, optional, enables UDLD in aggressive mode on the specified port. Note: use the no UDLD port interface configuration command to disable UDLD on a specified fiber optic port. Enabling fast UDLD on an interface. Message timer interval configures the period of time between UDLD probe messages on ports that are in the advertisement phase and are detected to be bidirectional. Note: fast UDLD can be enabled only if UDLD is already enabled on the specified port. Enabling fast UDLD on an interface. Message time interval configures the period of time between UDLD probe messages on ports that are in the advertisement phase and are detected to be bidirectional. Note: fast UDLD can be enabled only if UDLD is already enabled on the specified port. Monitoring and maintaining UDLD. Show UDLD interface or neighbors displays the UDLD status for the specified port or for all ports. Show UDLD fast hello interface displays fast hello information for the specified port or for all ports. When a link failure is detected by fast UDLD, the unidirectional link is error disabled by UDLD after displaying the following message on the console. If the UDLD fast hello error reporting is configured, when fast UDLD detects a link failure, it prints the following console message instead of error disabling the affected port. The UDLD reset command can be used to clear the UDLD port state in both the cases. This marks the end of my notes for UDLD Layer 2 protocol.